Hello, everyone. Today, we gather to address the questions of what can literally make or break an installation, which is the very topic of standards and commissioning. Today's conversation explores standards in practice. Standards are not just a checkbox exercise, it's a fundamental aspect of having your install done right. I say this every week, and I mean it every week. We have the best folks to share with you the insights today. Today, we're going to start off with Jeremy Begley, who will take us from design to standards. From there, we have ACCA's Wes Davis, who will take us into ACCA 310 and their application to residential heat pumps. And then finally, we will transition over to Ben Lipscomb from NCI, who will dive into ASHRAE standards as well. So today we are going to cover some really hard-hitting topics, the criticality of a performance-based approach and its applicability to heat pumps, along with the challenges that come with it. And so with that, I'm excited to introduce our first speaker, Jeremy Begley. If you've dialed in before, you will recognize him. He is the founder of HVAC 2 Home Performance, a consultancy focused on residential and light commercial testing and balancing. HERS rating, BPI energy audits, and LEED home ratings. He is also the founder of HVAC Design Partners, a venture focused on high-performance HVAC design, testing, and commissioning for custom single-family residences and commercial multifamily buildings. So Jeremy will introduce both the challenges at hand and the criticality of standards and how the intersection of design and commissioning impact day-to-day operations. So with that, I'm going to hand it over to you, Jeremy. Thank you for your time today.
Thank you, Shelby. Hello, everyone. Thank you for joining us again. We appreciate everyone coming back and checking us out week in and week out. Today, we're going to be talking about something that's near and dear to my heart, which is residential HVAC commissioning. It's one of the biggest, in my opinion, and also a lot of other people's opinions out there. It's one of the biggest missing pieces of residential HVAC in today's market. There's a big difference between what's considered startup and which is also has varying degrees of what actually qualifies as a true startup, and also commissioning. So today we're going to focus on two standards that will create a complete commissioning process for your shop and your team, and help you better understand how to make sure that the HVAC system is operating the way that the OEM manufacturers intended it, and the way that the HVAC design itself intended it to be implemented and set up. So the first standard that we're going to talk about is the ACCA 310, ACCA ResNet 310, ANSI 310 standard. The second standard is the ASHRAE 221 standard. Both of these can be used as either parts or whole commissioning tools. The ACCA standard can be used as a standalone prescriptive way to make sure that the designs meet criteria. The design meets criteria set out by some green building programs or ACCA themselves. And the ASHRAE 221 standard is a performance-based standard that actually allows you to put a score on the performance of the HVAC system and actually calculate the actual BTU output of the system at the time of testing. So in combination, this creates a very nice commissioning package. So very quickly, I don't think I have much time left here, but I'm going to run you through the design review process, which is step one in the ACCA 310 standard commissioning standard. So what you see here on the screen right now is the first page of the ACCA 310 commissioning report that the design side team is required to turn in to the rating team or to the HVAC contractor who is doing the commissioning of the system. I say HVAC contractor or rating team because there is two different pathways to perform this commissioning. One of them is as an HVAC contractor using the ACCA standards that Wes Davis will talk about here in just a minute, or as an energy rater trying to qualify a home for Energy Star certification, and that pathway would be the Energy Star pathway. What you see here is the HVAC design reports that are required for the Energy Star compliance pathway when using this standard. We don't have time to run through every single thing on here, so I'm going to point out some key points that are used in the actual 310 process. Uh, this tool that you see here is a tool that's available on ResNet's website. This is the standard 310 data tool. What it is a workflow tool that takes you through the entire workflow of the 310 process. It starts out with a first page being a project summary. And so this is something that the rating team would use to grade the HVAC system as they walk through the process. So it's very, very useful. And I see in the chats that they're having some trouble with the YouTube side of things, and Ben from MeasureQuick just put a new link for YouTube in. So if you guys are trying to get to YouTube, there is a link up in the chat for this for a different YouTube channel where you can stream it at. FYI, I know a lot of people said they enjoyed the YouTube streaming more than the LinkedIn streaming, so that link is available. So okay, back to the tool. So the tool, the project summary is just going to be project information, basic information, your rating team information, and then this page flows to every single other page in the tool. So you can always come back here and check and see if something is in compliance or not once you get done filling out the different metrics. So you can see basically everything is a no, 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 no right now. And it's going to show you as you go through the different field inspection pieces, what method is actually being used. And Wes is going to talk about the different methods and the different field pieces, but what method is actually being used to verify that particular piece of the 310 process. So you got all 5 steps. And so we see HVAC design review. Right now, the tolerances are not met. So if we click to the design review tab, and sorry if there's a lot of scrolling back and forth, but we were trying to come up with the best way for everybody to be able to see this. And so zooming in was our best option here. So some of it's cut off. So you're going to have to bear with me as I scroll back and forth through some of this. So you'll see just very quickly in this, the first part is exactly like the or I'm sorry. So the first section of this, I should say, is exactly like what you get from the HVAC design report that prints out. It's all this information. And so one of the simple criterias of this and also the other Energy Star, when we were using the other Energy Star design report, step one that the raters are supposed to check for is all items are filled out. Very important, because if you miss something, then that means that something is probably not meeting the criteria, or the person that is doing the design hasn't verified that something is meeting some of the criteria, some of the design criteria. So the design description is optional. I usually use that just to say what type of system's installed. This is a single stage heat pump with a ventilating dehumidifier. So that's what the system is. Designing company, pretty simple stuff. Designer name, pretty simple stuff. And then we get into the ventilation pieces. So this is asking you compliance questions. Did you verify that the ventilation and airflow rate meet uh, ASHRAE 6210 or later per Energy Star requirements? Is there an access? This one right here is really actually important and something that is very helpful to the raters out in the field or the HVAC contractor that's commissioning this. This is where in the heck can you test your ventilation system at? So you all the time, like out in the field, this is a big deal because like we get calls from raters constantly like, this is the type of ventilation system that's in, like this is how it's ran. Can I send you, I swear I get these calls all the time, can I send you some pictures, can you show me where to test it at? Like some of the stuff is pretty straightforward, some of it is not. So I like that Energy Star put this question in there: identify the access point where the rater is supposed to measure the ventilation flow at. Like get specific with it. And so usually on our drawings, you won't see it on this drawing today because I didn't have time to put the ventilating dehu in and all that for demo purposes, but I will circle with a big red circle with an arrow on it. Like here is where the ventilation should be tested at. Uh, and and so then these are just basic ventilation questions that go through verifying what kind of ventilation system is in and if it's meeting the requirements of Energy Star as far as the way that it's set up and it's operating. And then there is some stuff you'll see like here at 2.9 MFMC only. So some of the stuff only applies to multifamily. That is one thing that's happening here. Um, that you have single family and multifamily mixed in together, and there's only a few things that are different for the living units and multifamily. Now there is a fourth supplemental sheet that goes with this. It's not in this particular set of documents that I'm showing you here that is for multifamily, and that's the common area verification sheet that goes with this. So that would be the fourth document. That is the only document that will not print directly out of RightSoft or Elite. Now, these forms can be filled out by hand, but unless you're an engineer, and this is our own personal preference from review on the Raider side, when I'm doing Raider reviews for this stuff, and we're getting them from the designers and I'm reviewing this stuff as a rater, I will only accept this documentation if it's printed out of RightSoft or Elite software. If they're using some other software that doesn't give you the ability to print this stuff directly out of the software, then we have to make allowances. And if you're an engineer and you're using like Train Trace or a Carrier HEP or something like that to do your load calcs, then you're going to have to fill this out by hand, and then you're an engineer putting a stamp on it. But the reason that I personally won't take anything unless it's filled out by the software is because I know for sure that what they put in their design is on this sheet. There's no way that they can change it and make it something different than what they put in their design. And what I'm going to say next is not a knock against any individual HVAC contractor, but I have found that engineers are way more interested in putting the exact data that is in their design in this form than an HVAC contractor filling it out by hand. Typically, HVAC contractors put in whatever makes it look right, whether it's what they're actually installing or not. So that is a reason that um, I feel that it's super valuable that this can be filled out by the software and you're able to request it that way. And that's a personal preference. There's no thing out there, no standard by any of these organizations to say you have to do it that way. But for me, that is a very nice fail safe to make sure that I'm getting the most accurate data to the design handed to me. And I do the same courtesy. I'll never fill it in handwritten. I print it straight out of the software when I'm on the design side and I'm handed it in for review. I will always give you what comes straight out of the software. So let's get back to this sheet really quickly here. 1 minute warning, 2 minute warning. I'm almost out the door. So I just really quickly, I'm going to run through some of this. I'm not going to jump back and forth, but you see the metrics that are reviewed during the design are real similar to what Energy Star is always required, except it adds in a few things. So we were always required to review conditioned floor area, but now the metrics have gotten a little smaller in 310 than they originally were. So you have a less of a variance for air that's allowed in 310 than it was on the other side of Energy Star. Same for the windows. We were always required that. So in my house, 1,300 square feet is what's in my design or something like that, 1,320. Would that comply? No. You have to be within 300 square feet of the home itself. So once I put the actual home in, 1,300, let's say, and yes, it complies. Same way with windows. You have to be within 60 square feet smaller and 15 square foot larger. So think about that, guys. 15 square feet of windows. And then there's some other stuff for smaller homes, like way smaller amounts of windows and things like that, where you get into percentages instead of actual prescriptive metrics. And then heating and cooling methodology, if what you're using for orientation and does it meet the orientation criteria. And then you get down here, you got some stuff that's in multifamily, but if you scroll all the way past your multifamily stuff, then there's some more questions that have to do with all dwellings, town units, sleeping units. Design documentation Has it all been collected? Are you using the right design temperatures? Number of occupants? Does it match bedrooms +1, ±2? What's your predominant SHGC? What's your predominant above grade wall R value? These are new now. Like for 310, these aren't in the HQITO compliance pathway for Energy Star. You don't have to review per the rate of review. You don't have to review installation metrics. I'm super glad that they added this stuff because it's one of the biggest load swingers out there. It was crazy that it's not in the other pathway. And then your infiltration rate too. You can either use the qualitative or the quantitative, depending on what you want to do. We typically always talk about ACH 50 for when we're talking about infiltration and designs. It's usually the most accurate way to predict infiltration in the house. The other way, like tight, loose, you can use that stuff on here, but it's not that great, and I don't recommend it. And then your mechanical ventilation rate is reviewable, and your HVAC equipment types and zones, cooling served, and then your design airflows are a big deal. So this is not accurate for the system. You'll see later we have a different airflow for this system, but those have to go in here and they have to match the system airflow in the design report has to be stated. And then here you'll get are you in compliance or not? So now I know I ran a little bit over time. I wanted to get through those, and we'll do a different webinar later on where we dig closer into this stuff and show you some real meat and potatoes of how this stuff can either be good or bad or otherwise. But this is just a basic overview of the standard.
Awesome. Thank you so much, Jeremy. That was incredible. And it shows you the depth and the breadth that this covers, which is not insignificant in any way. So with that, we're going to hand it over next to Wes Davis, who is the Director of Technical Services at ACA and manages the development and maintenance of these standards. He oversees HVACR education and supervises the Quality Assured Contractor accreditation. Wes was a certified technician, a licensed South Carolina HVAC contractor, serves on ASHRAE technical committees and the ResNet's standard management board. So it's quite a few different exposures to standards and implementing them that he has. And he's now going to deep dive on these areas, specifically Standard 310 and Energy Star with us today. So over to you, Wes.
Thank you, Shelby. And I do need to amend my bio briefly. I no longer serve on the ResNet Standards Management Board. Just a quick clarification. Jeremy, great job walking through that.
Thank you.
Real quick, I wanted to touch on something. You were diving deep on the design, and I appreciated that. I was going to say that the design cornerstone to a quality installation, and it's very important to ensure, you were talking about the metrics and window sizes, floor area, et cetera, that the home does represent, that the home that's built does represent what was modeled. But it's not impossible. If you do find that, hey, we did a bump out in the master bedroom, or we've changed the insulation package, or we put in some skylights, that's not the end of the world. You can still modify the design. It's just that you do need to do those steps to make sure that the HVAC system you're going to install and the duct system that you've designed is going to fit that home. So good job.
Thank you. And I agree 100%. The design has to match. That is the biggest point. The design needs to match the home being built at all times up until the point of installation. And there are some things where, I get guys freaking out all the time calling me saying, this changed, man. We went through that whole review process where they did this or they did that. And like, it's just, hey, just have your designer add that stuff in, send it back to us, and let's make sure what you're putting in still fits. That's all we're doing. We want to make sure that you're not going to have any problems and the homeowner isn't going to have any problems. That's all.
Exactly.
Yep.
Exactly. Yeah. And changes are allowed. Yep. All right. So we were going to talk about the tasks 3, 4, and 5, which are measuring airflow, fan watt draw, and refrigerant charge. And so I wanted to take just a minute, and please feel free to chime in, Jeremy.
Sure.
There's 4 different options for measuring airflow, and airflow is after we get past the design, making sure that the foundation is laid, if you will. The next key element is making sure for a forced air system that we're moving the right amount of air through the equipment. That's vital for the equipment's operation. It's vital for how well the comfort's distributed throughout the house. So there's, as I said, 4 different ways to measure that. Probably the most popular way that HVAC professionals, at least, use is either static pressure or the true flow grid. There's 2 other procedures you can use: a pressure matching method, and that involves connecting a powered fan, like your duct blaster fan, to the system, and you're you run the system first, measure the static pressure, and then you connect your fan, and you're dialing in how much air is moving through that fan into the system. And when you reach the same static pressure that the equipment was delivering before, then you measure the fan flow, or the flow through the fan, and that tells you how much air is flowing through the system at that previously measured static pressure. I'm going to pause there for just a second, Jeremy, to make sure I didn't miss anything, or see if I need to add
No,
anything to that specific procedure.
no, I agree. I like everything you said, and I just want to say that the flow grid's probably the easy. Like having a flow grid, whether you're a rater or an HVAC contractor, is the thing. If you're going to be doing this commissioning, even if you're not, like I actually worked with a couple shops that kept the flow grid, HVAC shops that kept the flow grid in the shop just to be able to measure total airflow as they commission the system, because it's
Mm-hmm.
such an accurate way to do that, and it gets you most places. Like all these other methods, even the static pressure method, at some point in time you're not going to find a fan chart, and you're not going to be able to verify that way necessarily. And so having the flow grid, in my opinion, is probably the get you most places piece of equipment to use.
Right. Yeah. And so the flow grid slides into the filter slot, and you're measuring, and it's basically a small set of pitot tubes that traverse the airflow through uh, that test system that's sitting in the filter slot. So very, very accurate. Uh, they've done some modifications so that they are able to compensate for some weird duct configurations that you might experience out in the field. So yes, I agree. True flow grids, awesome tool. Going back to the static pressure matching, that's awesome. That's what I grew up using, and I love it for a like new piece of equipment. If you've got an old fuzzy blower wheel, or if you've got a coil that's not pristine and clean, especially if you're using working on a fan coil unit, measuring static pressure can be a little wonky. But if you've got a nice new clean piece of equipment, it's hard to beat.
This really quickly too. This is what
Hmm.
we're talking about here, guys. This is the fan chart. So this is from the actual example that we're using. I don't know how much we're going to get to dig into the example, but this is the example that we have set up for you guys. This is the actual air handler fan chart. And so the cool thing about using the fan chart is it's what the designer should be using to set up the airflow for the installer when they install the fan. So the designer should not just be using a nominal amount of airflow, like 400 CFM times however many tons it is, and that's your airflow. And that's what traditionally guys have done for years and years. But the correct way in the order of operations when you're doing a design is to do your manual J, get your load calculation, then when you're doing your manual S matchup, after you match the BTUs of pieces of equipment at design conditions to your load calculation, your next step is when you're selecting your piece of equipment, go in to the chart for either the fan, for the air handler or the furnace, and find the closest airflow to the airflow that you need, and modify your airflow in your design to match what it can actually put out at your design static pressure. And so that's what you see here. You see, if we're going to design a 0.5 inches of water column, then our airflow that we need closest to the airflow that we're trying to produce is 543 CFM, and that's what goes into our design. And so that is what's in our design here today that we're using. So that's why, Wes is saying he grew up on the fan chart. That's why, because HVAC guys only ever had the fan chart and a manometer to measure static pressure, and that's what they're going by when they're setting their systems up.
And you raised another good point, Jeremy, and that is if you really wanted to hit something between those two numbers, let's say you wanted to hit 550 or you wanted to hit 560 or 600, you could interpolate between those static pressure values to get the design static pressure that you're looking for, and that goes into the duct design. And we're not going to spend too much more time going back to design, but static pressure, thank you for popping this up. So for this model, I can measure the static pressure. This is a furnace. This is a fan coil.
It's an air handler. It's a
This is an air handler.
Yep.
So I'm measuring at the return and the supply. Based on, do I have a filter in here?
Yeah, you'll have a MERV 13 filter in there.
So I got a MERV 13 filter. So if I've got that MERV 13 filter, I measure static pressure, then I can go back and equate what I measured to what that fan is producing, what it's moving through the system.
And I'll show you.
Very important.
Since you brought up filter, I'll show them something else really cool, really quickly here. So
and while you're bringing that up, if you change that filter out, if you just put in a hog hair filter, or you wanted to go to a higher filter, you can. You just need to, and there's an adjustment that's built in, and you can deduct or add to the static pressure that might be affected by that filter.
Exactly. And this is on the design side, guys. We're going to, like, if you're doing your designs legit, right? Like, you should try to find out, and I do this with the installer. Like, if I know who the HVAC contractor is, I say, hey, what brand of filter are you using? And then I go to whoever's making the requirement, what MERV rating are we going to use? And then I go and I look that filter up, and there is a pressure drop associated with that filter that the manufacturers now all produce. A long time ago, when I first started doing this, it was so hard to find pressure drop for filters, but now they know that it's a big deal, and they've gotten a bad name for degrading systems and causing system failures and stuff like that. So they all publish their static pressure. You can find the pressure drop for every filter, and that's on a traditional, it'll tell you what kind of rack and everything. So if you're using some different shape rack, you can change this to meet that. So for this particular filter, that is an actual drop of a filter that I went and looked up. So that's not just a made up number.
Jeremy, you're hogging my show. Okay, so the fourth way to measure airflow, and then we're going to move on, is you could use a flow hood. And the challenge with most passive flow hoods or capture hoods is they struggle with accuracy, I think is a good way to put it. But if you've got a fan assisted pressure compensating flow hood, then you could use that to measure all of your supply ducts, all of your, I believe that's our I take that back. On the return, you measure the flow through the return to evaluate what that, or approximate what the flow is through the unit itself. And so of all the procedures, that's the one I would probably not recommend the most. But you've got a lot of other options.
Is there a restriction? I think it's 3 or less returns per the standard that you.
Very good. Yes.
You're allowed to use that. Yep.
Very, absolutely. Another reason to use something that's a little more accurate, a little more tried and true. Absolutely. And Jeremy, I'd like to point out that in my opinion, I think that standard 310 is a great opportunity for a symbiotic relationship between a rater and an HVAC professional. I think if the rater does what they're good at and the HVAC professional does what they're good at, I think there's a real opportunity for the information to be collected, shared, and the home gets the benefit of a lower energy rating index. The builder gets a better reputation, and the HVAC professional is going to get a pat on the back for doing the job right, as they should be doing.
I'll go on top of that too, and just say that from a personal experience, I've seen two things happen. One, the HVAC contractors love this, and they're always trying to prove that they're the best, and they want to do it. And they get the rater's phone number, and then them and the rater become best friends, and they're calling them and saying, "I did this. This is how it's set up. When are you going to be out here?" And then it goes the other way too, where they feel like it's somebody watching over them, and you're trying to see what I do, and we don't like it, and it's a feeling that you're there with a big old stick to whip them with, and like that is not the relationship that's beneficial to anybody with this stuff. Like Wes said, like, it can be a great thing, and it really can add value on both sides if everybody looks at it from the right perspective.
Uh, and we need to promote the guys who want to demonstrate that they're doing it right, uh, to encourage the people who are worried about Big Brother looking over their shoulder. And I think it's probably an experience thing. It's something new. It's a change, and so that feels a little weird. It may be a confidence issue. I don't know if I'm doing this right, or if I'm taking a set of plans with this wonderful duct design and I throw that away and I say, I know how much air goes here and how much air goes there. I'm going to do this. Then everything's out the door. So, yeah, we need to promote the guys who do it right. And so, to get back on track, the next task is measuring fan flow per watt. And so, after we've got the right amount of air going through the system, it's very important to make sure we're not over stressing that fan motor. If you got the right amount of air flowing through, but you're pushing against an inch of static or more, then that's going to really stress that motor. So one of the next steps is to make sure we've got a nice duct system that allows that fan to loaf along and move the air it needs to move. And so there's a couple of ways that this can be done. For the HVAC professional in the field, it's very simple to measure the watt draw, and either volts and amps, or if you've got a multimeter, you can just measure the kilowatts going in. There's other ways. There's an interface that goes, if you've got a furnace, a plug-in furnace, there's an interface that goes between, say, an outlet and what you plug in, and it'll read the watts. And then you could also clock the electric meter outside if you were so inclined. So there's two ways. Anything pop in your head, Jeremy?
I got some questions for you.
Lay it on me.
Here's questions I hear, and this is mostly from the rating teams, but I do get them from HVAC contractors too, who are just getting into measuring this stuff. So let's say an air handler versus a furnace. If we just have a heat pump air handler, where's the best place to take watt draw at? What's the best way to do it? Like from a technical standpoint.
Right. I like to measure it at the disconnect. I like to take that panel off. I like to measure my voltage there, and I like to put my amp clamp right there and measure amps if I'm measuring volts and amps.
So let's say it's within 5 feet of the box and there's no real disconnect. Like, so, the breaker box. So a lot of codes, like especially in the markets that I work in, will allow you to get away residentially without a true disconnect if you're within a certain amount of feet of the breaker box. And so then you have to go to the air handler itself to measure it. So if that's the case, how would we do that? I don't mean to put you on the spot, but
yeah, it's a bit tricky because typically to measure that, you've got to take that fan door panel off. And so if you've got that door panel off and you're measuring watts or volts and amps, that fan is seeing an easy pathway. There's no real clear way to say, yes, that's the right way. So, and that's also, I guess, a warning too. If you see a contractor and they've got the fan door panel off and they're measuring volts and amps and saying, okay, look, I've got a really low watt draw, that's not an accurate measurement. There's some, what are you recommending, Jeremy?
So it's all about the equipment you have in this case, and that's what I want to make sure the guys are getting the right pieces of equipment. There's two ways I think to do this. One is Redfin manometer is a Bluetooth enabled manometer, or I'm sorry, a clamp meter. I don't know why I'm saying manometer, clamp meter.
Right.
And then there's also, I know that Fluke also has recently came out with a Bluetooth enabled one. So those guys, they have apps with them. You could put the clamp your Redfish meter or your Fluke meter with the Bluetooth on inside the fan thing, button the fan cabinet back up, and read it off your app. That's one way to do it that I've found that's super easy to do. The other is the old school way that all us tab guys know, and that's get you an extension for your amp clamp. And they're expensive, but they're worth having. And you just hook it inside, do the same thing. It plugs into your clamp meter, and you just extend it into your put it in your cabinet and close the door back, have your little cord sticking out, just a little bit. You can get it nice and tight it's not going to mess your clamp up, and read it that way. But you do have to have a tool that will allow you to read behind that closed fan cabinet door, because a lot of times, like Wes is saying, that's the only way to get a true reading is on the wiring that's in there. So the rest of that's a lesson for another day to get into what wires and whatnot, but that's a good general tip that I wanted to make sure we got out here, because I hear that a lot when it comes to this particular step here.
Good point. So the last item, Jeremy, is refrigerant charge. And again, this is where HVAC professionals should really knock it out of the park. They should already have gauges connected, because they're vacuuming the system to at least 500 microns and watching that for a few minutes to make sure the pressure doesn't rise. They're evaluating the line set to see if they need to weigh in some more refrigerant or not. And then they can, when they start the equipment, if the temperature allows, they can measure superheat and or subcooling. So that's a very easy way for an HVAC. We were talking about earlier about that symbiotic relationship to connect the rater and the contractor so that they share information. I think the rater is the perfect person to do the duct leakage test. I think the rater or that HVAC professional could do the design confirmation. So the evaluation is one part of it. Some third party really needs to take a look at that to confirm it's accurate. But then at dry in, just before we're putting on sheetrock, I can confirm insulation. I can confirm the floor area, window area, all those attributes of the home. Yes, this home was built like it was modeled. And then, of course, we just talked about airflow, and with refrigerant charge, they're right there. They can take the measurements, and or if it's the middle of January and we're setting this air conditioner, I can weigh in that refrigerant, take some pictures, share that with the rater, and let them know that come spring, when this thing does get started up, we got a really good chance of this system operating exactly as the manufacturer wanted.
So Wes, what are the two ways, just so everybody's clear? Because there's one way, superheat and subcool is not allowed in this particular methodology for measuring refrigerant airflow. So what are the two allowed methodologies here?
So we've got the weigh-in method, and then there's a non-invasive method, which really depends on what the contractor did with their charge. But you're measuring the entering air condition, wet bulb and dry bulb, measuring the outdoor ambient temperature, and then you're measuring the line temperatures. And there's a procedure in the standard that lets you plug those numbers in and have some confidence that the refrigerant charge is accurate.
And last but not least, I know we're up against our time here, but I do want to get this in. There was some confusion the way the standard was originally put out and written that made it sound like and seem like to some contractors, and even I thought this, that you had to weigh in everything, or if you couldn't use the non-invasive method per the standard, you had to weigh, no matter if it was a packaged unit, a ductless, or whatever. And I know that ResNet has now adopted some amendments that are going to be written into the new standard, and I was wondering if you could just touch on those for us really quickly.
Sure. Yeah. With packaged equipment and with mini splits, typically there's pre-charged line sets, and we're using a rotolock type fitting to secure that, so there's no need to evacuate the line sets. And with a package unit, there's no need to remove the refrigerant charge and weigh it back in. I mean, great Scott, that's what they did at the factory. So, and the ResNet amendments to the HERS, the MIN-HERS standard, are final. It's addendum 53F. So those are rolled in. If someone is asking you to show that they evacuated the system and weighed the refrigerant charge in for a package unit and or a mini split, there is an alternative path. They can get grade 1 for a package unit, and I believe for a mini split as well.
Correct.
I got to reread 53F just to make sure on the mini split, but that is my recollection.
I think that you're right, but I'll say let's let everybody read it for themselves to make sure they're interpreting it exactly correctly.
And
Thank
on
you
that
all.
note,
Thank you.
thank you both so much for sharing all of those thoughts. And for our third and final individual speaker today, we will bring on Ben Lipscomb, who is an engineer specializing in commercial and residential HVAC energy efficiency. Ben joins us from National Comfort Institute and brings a ton of experience ranging from energy efficiency program design and implementation to policy and regulatory consultation, measurement and verification, laboratory and field research, application of codes and standards, really runs across the board. So with that, I'm going to hand it over to Ben to share a little bit about the different standards and talk a little bit about the ASHRAE standards.
Thanks, Shelby. Let's see. So I guess in addition to those things that Shelby rattled off about me, I was also involved in the development of ASHRAE Standard 221, which is a standard to test and measure or test and score the cooling and heating performance of an installed HVAC system. So this is something that is intended to be used by HVAC professionals, field technicians, sales folks, basically anybody with the expertise to go out there and handle the instruments that are required. Pull up my screen now. So this is the actual ASHRAE standard. It was written a little bit differently than a lot of ASHRAE standards in that it's written as much as possible in terminology that a layperson can understand, or more importantly, terminology that an HVAC field technician can understand. So a great place to start with this standard, if you're looking to use it, is to go out, buy the standard, read it. You're going to be able to understand it. The standard includes, lots of different alternate test methods and things like that, and instructions on how to actually make the measurements and start up the system and things like that. So great resource to have. The other thing that I would say you should get is a copy of this calculator. We have it available on our website. Might be available in a few other spots across the internet. But this calculator was designed by the 221 committee. It's in beta version right now. But you can download this calculator, and it really makes doing the calculations in the standard a lot easier than if you were to try to do them by hand. I expect that soon we'll see lots of different apps and things like that incorporating 221 calculations. So I look forward to the day when we can do this all on our phones. But for now, this is an Excel spreadsheet. The other piece up front here is I want to talk about the instruments that are required a little bit. So these are all the instruments that are listed in the standard. You've got a capture hood, a digital anemometer, a digital manometer, and then a multi-sensor thermometer or psychrometer. And then if you want to do the EER, field EER option in the standard, you need a power meter as well. As far as, bare bones, being able to apply the standard with the minimum amount of instrumentation necessary, you're going to need at least a capture hood and this multi-sensor thermometer psychrometer with 7 probes. So those are the instruments required. So now I'll jump into this calculator and kind of walk you through what this actually looks like in the field. And I'm going to base this on the design that Jeremy and Wes were just talking through that Jeremy supplied us. So thanks for that, Jeremy. The calculator, it's an Excel calculator. You've got a cooling test and a heating test available. We're going to go through the cooling test today. So it's kind of set up on 2 pages, and I'll kind of zoom out a little bit so you can see. The first page is where all your kind of general product or project information and equipment data goes. And then it also displays your results. And then the second page is kind of where more of the detailed actual measurement data go. So a lot of your field inputs will go down here. So let's go ahead and zoom into this first page again. You got a key up here for what happens and where you're supposed to put values in and things like that. general project information. That is all required by the standard just for documentation purposes. Your equipment data. So you've got, different options for package units and split systems, and if it's a furnace or a heat pump and things like that. It also does support either EER or EER2. One thing about this standard is that it can be applied to a new system, like we're talking about for commissioning today, or it can be applied to just any existing system that you walk out to in the field, and you want to see how it's performing, maybe make some improvements to that system, and then you could test again to see how much you were able to improve the system's performance. A little bit of system data, just the area that you're testing, your total number of supply registers and return grills. You are required to either draw or obtain the plans for the project. So for this, new example, I have this design from Jeremy. So I've got the floor plan there. I count up the supply registers and the return grills and just put that into that input there. It's a new system, and everything's clean because it's brand new. And those are all the inputs on the first page. So then down here on the second page, we have to document what instrumentation we were using and when it was last calibrated as a part of the compliance with the standard. So I've got a capture hood from Almor, a multi-sensor psychrometer from Fieldpiece, and a watt meter from X-Tech on this particular one. And those are all documented. Then there's some system startup checks. So here you have to go through and verify that your outdoor air temperatures are within range for this cooling test, your occupied space temperatures are within range, and your coil entering wet bulb is within range. And then you're going to turn off separate exhaust systems. You're going to set the controls to call for all stages of cooling. We don't have an economizer. We're going to close all the windows and doors, put the doors in the normal occupied position, whatever you think that might be. And we're going to go ahead and turn off any auxiliary fans. So after all that's done, you fire the system up, you let it run for either 15 minutes, or there's another option for looking at the rate of change for the supply air temperature. And when that stops changing or it gets below that threshold that's in the standard, then you can go ahead and test. But in general, the 15 minutes works just fine. The other option is more for situations where you might have a very low load in the space, and when you're running the system, you're unable to keep the temperature requirements over here true for the entirety of the test because of that low load. So you can kind of shave off a little time in the startup there if you want to use that more detailed method. As far as the measurement data, you're going to go ahead and get your outdoor air temperature and your equipment entering wet bulb. So this is actually the wet bulb temperature at the return of the equipment. And then if you want to do what is called ICS EER, that's installed cooling system EER. So it's a field EER measurement. You're going to need to make a watt measurement, and you're going to get the total equipment power. So what's going into the outdoor unit and the indoor unit if it's a split system. And then you're going to get just the supply fan power by itself, because the calculations here actually require us to separate out that supply fan power, make the adjustments to the total equipment power based on the conditions that you're testing in, and then put the supply fan power back in. And then where this differs a little bit from what's required for airflow in 310 is here we're actually measuring with a flow hood typically the airflow coming out of the supply registers and going back into the return grills. Or sorry, you don't need the airflow going back into the return grills, just the supply registers. And then we're going to measure enthalpy with our, I guess we're using that Fieldpiece psychrometer here on at least 3 supply registers and at least 2 return grills. So here I just put in the same number for all these. This was not a real test. This is a, mock test based on Jeremy's design. So we put all those in, and then we're done. It takes about, well, there's like, 5 minutes of documentation required, 15 minutes for that startup. Go ahead and make your measurements. On a typical house, this test method takes about an hour. So now we scroll back here and we can see that, we got 100% for our cooling system performance ratio. So what that is it's the actual measured BTUs going into the occupied space divided by the rated BTUs of the system under the conditions that you're testing in. And I'll show you that in a minute. And then we've got an installed cooling system EER of exactly 12, which is what this system is supposed to be. So this system is perfect. You won't often see this in the field because of a couple different reasons. One is the field installation is typically going to differ from the lab setup that was used to calculate the EER and capacity ratings for the system. So you're always going to have a little bit of variance there. And then also the instrumentation has error, plus or minus some percentage for each of those pieces of instrumentation, and those errors add up. So what I would look for on a brand new system, if I was commissioning it and I wanted to score it with ASHRAE 221, is something within plus or minus 10% of this 100%. And you can get over 100% because of those instrument inaccuracies. And then something within 10% on the EER as well. So that's what I would look for there. Let's see. There's one other thing I wanted to point out here. Yeah, so right here, the rated gross cooling capacity. There's some of these numbers that you're going to want to actually dig into the manufacturer data to get. So this is a 1.5 ton system, but under the design that Jeremy supplied, it's actually not doing 1.5 tons. It's actually going to be doing 16,910 BTUs per hour, approximately. So how did I get that? Well, Jeremy was also nice enough to supply all the documentation for this piece of equipment. So what I'm going to do is I'm going to go to these detailed cooling capacities tables. These look similar for most pieces of equipment, just a little bit different. But what we're looking at for is the rated gross cooling capacity under our standard conditions. So 95 degrees outside, 67 degree entering wet bulb. Those are the standard AHR rating conditions. So here we see it's 16.91 MBTUH. So 16,910 BTUs per hour is what this system is really rated to provide under the design conditions here.
Hey Ben, can I say one thing real quick? I just want to throw even a cherry on top of this.
Absolutely.
You can take your manual S calculation, which is based on this chart, and instead of using just 95 as the AHRI data, you can take this one step closer. And this is what we do personally in our company. We use the actual manual S total capacity at design conditions. So for Cincinnati, where I did that design at, we're looking at something in between 85 and 95, and we're interpolating that data because our design temperature is 89 degrees. So it's not doing exactly 16.9 at our design temperature in Cincinnati. It's doing something in between there. So you can get down to the nitty gritty and put that number into the stuff that Ben's showing you and get an even more accurate assessment of what that piece of equipment is doing at true design temperatures. That is the real gold with this standard. Sorry, Ben. I just wanted to make sure that people heard that.
Thank you for bringing that up, Jeremy. And I do want to point out in this calculator, there's two methodologies that you can use in the standard. And one is to go and get the actual, what is the equipment doing, or what should the equipment be doing under the test conditions. So you can actually, go look at this chart and, say if I'm testing when it's like 75 out, I'd expect to see 18,740 BTUs per hour. Or, if I have 62 wet bulb is probably more accurate for what is coming into that equipment. So if it was 75 with a 62 wet bulb coming in, it'd be more like 17,070. So that's kind of what Jeremy's talking about there. So you can put in just that number and use that to run your calculations. The other option is you put in the AHRI rating conditions number, and the standard has some generic performance curves built into it, or tables that allow you to adjust that back and get an estimate of what the equipment will do under your test conditions. So there's a couple different options there. I believe the calculator uses that second option. So you're just going to put in the rating condition in the calculator. If you wanted to kind of hack the calculator, what you could do is put in your actual gross cooling capacity under your test conditions, and then come down here and put this capacity adjustment factor to 1. So that would be kind of a hack for the system, but really this calculator, is looking up in tables from the standard an adjustment factor, and it happens to be 0.94. So we'd expect our capacity to be 94% of that gross rated capacity under our test conditions, which are 89 degrees outside and 62 entering wet bulb. So a few different options. Let's see. So yeah, it's important to have access to this manufacturer data so that you can look up what your cooling capacity is there. Let's see here. Airflow, what else did I want to talk about? Yeah, so if you're going into the field, oftentimes you're not going to have access to a design. If you're going into an existing home and you're testing a system that's there, or you want to test a system that you just installed or retrofitted into the home. So the other option, if you don't have that design, you can go ahead and just sketch the home and sketch in where all the registers are, and that's really all you need. If you can get the design CFM for those registers, it can be a handy diagnostic tool, because you're going to go through and measure all these, be able to compare, what should it be versus what did I actually get. In this example here, I just put in exactly the airflows from the design. So, that's why we ended up with this 100% exactly 12 EER2. Let's see. Jeremy, any color commentary to add to this?
One thing I will say is, like, your prediction of it taking an hour in the house, if you're already doing 310, you can work this in with the 310, and it takes less than the full hour, because you already had your time counted in for what it was going to take to do 310, and like letting the system get started up and running and stuff like that. Then all that's already taken care of, getting up to steady state. Like, those are things that are required for both of these standards, that once you get your system up to steady state, that's 15 minutes of your time right there that was already accounted for both of these things. So then you can go back in and simultaneously work some of this stuff in. And so, like, we've got it down to about 35 to 40 minutes in the house if we're doing both standards. The 310 takes a lot less time because it's a lot less involved than it does. We're probably at around 15 to 20 minutes, maybe 30, depending on any anomalies and stuff like that, doing a single system 310 testing. And then it's probably another 25 minutes to 30 minutes to do the rest of the stuff that is required here. And sometimes if if it's two guys in the house, you can cut that time, down significantly, because you can work together. Having Bluetooth probes helps a lot. Like, there's a lot less running back and forth. If you're using Bluetooth probes, that can cut into your time too. So that's an important, I don't want guys to get scared away. Like, well, we don't got an extra hour to put into doing this. But the value that this piece provides right here cannot be stated enough, because it's giving you actual BTU output of the system operating, and it's going to let you know right then and there if you need to go back and see if something's not working correctly, or if you have some kind of problem, what it could be. Like 310 will vet some of that stuff out, but this right here is going to be the cherry on top. It's going to let you know for sure how that system's performing when you walk out the door, and you're able to put it on the system itself. I know NCI has some programs where they, if you're part of their contractor network and you're using their software, you can now print out a sticker to put right on the equipment, saying when we tested this particular piece of system after install, it was doing this number. So then from there, you as the installer, I'm talking mostly to the HVAC contractors of the world here, you guys know that your system was performing correctly when you walked away from it. So if something else happened, if it's not doing, not working correctly, or you're getting comfort complaints, especially in new buildings, you can say, hey, maybe you should look at the thermal envelope before we come back and do a full diagnostic of the system, because we know for sure that system was producing what it was supposed to do when we walked away. So I don't want the value of what this is to be understated, because it is immense for HVAC contractors.
Yep. Yeah, certainly. It allows you to show your customer that they got what they paid for with the system that you put in. The other way it can be used is actually as a sales tool. You wouldn't necessarily want to do this on every sales call, but if you're getting into a high-end job that's going to cost the customer a lot of money, it can be a great thing to go and test their existing system and show them, hey, this thing's not performing. We can do X, Y, Z and put it in a new piece of equipment and, fix the ducts and make it perform. And we're going to test out the same exact way we tested in. And, we're going to show you in 80% or better when maybe it is performing at a 50% now. So you can really put some numbers behind, what you're proposing to the customer in terms that they understand.
And I will add this too. I know we're talking residentially here, but my commercial guys, like, this works commercially too. You can use this on commercial ducted systems, and sometimes, like Ben was saying, it's even a better sales tool in a commercial application, because we get the calls all the time about this or that's not working right, and we need to know what's going on. And we've got 5 quotes from HVAC contractors to replace this portion, and this guy said replace something else. And so you can really dial it in and go in and do a nice little show for your customer on the commercial side too. I don't want to get too far into that, but this is valuable in both markets for sure.
Yeah. And real quick, I got a question from Shelby here about testing cooling systems in temperatures less than 55. For the standard, if you were to try and, rig something up to be able to test in less than 55, it wouldn't be a valid test, or it wouldn't be a test according to the standard. But you could do it. There's different ways that you can go ahead and kind of hack the system to be able to do that. It's going to be more difficult. And really the best thing to do in that situation would be to do a heating test on the system instead. So that's another option there. And then come back and do a cooling test. If you really need to do a cooling test, come back when the temperatures will allow you to get that done easier.
Fantastic. Thank you, Ben, so much for sharing all of this. So now I'm going to ask the additional 2 guests to join us on the screen. And we are going to answer a few different questions that have come in. Wes, thank you. Jeremy as well. The first question that we're going to handle is, can standard 310 be used on ductless systems? If not, what standards should be followed?
I'll take a swing at that. Am I muted? Can you hear me?
I hear
We
you.
got you.
Oh, great. Okay. So for one thing, ductless systems typically not the only HVAC system in a dwelling. I'm sure there are some arrangements, some open floor plans where it could serve a large area, but most homes aren't served by a single ductless split system. But the short answer is ductless systems just get a lot of breaks, right? So duct leakage, not existent. So that's an easy one. The airflow, much like the refrigerant charge, they get a pass for airflow. due to some of the test conditions and how you would measure airflow. There's also an exemption. If you have less than 10 feet of supply duct, you're exempt and you get a pass. Fan watt draw per CFM might be the only other item that could be evaluated. So design and fan watt draw would be the two elements that could be verified, and for everything else, it's easy sledding.
Yep. And the only anomaly on that, I think, is if there's line set length restrictions and you have to add refrigerant, then you would need to prove that way in. Is that correct in saying that? If it's like,
Right.
after 50 feet of line set, you need to add X amount of refrigerant, then it needs to be weighed in, and verified. And most of like Mitsubishi and all those guys, they print that stuff right in their literature. So if you follow their procedure, you need to verify that. There needs to be some documentation of that, put it that way.
Yeah, and I'll just add that 221 is also not set up really for ductless systems, because there's so many things about a ductless system that you just put it on and it works. So really, if you wanted to measure BTUs through a ductless system, you'd probably just have to assume the airflow going through it is per the manufacturer spec, and then you could potentially measure the enthalpies going in and out of the system and apply the formulas in 221, but it's not going to add as much value as for a ducted system.
Fantastic. Thank you.
Hey, this is Ben with Measure Quick. You guys can hear me?
Yes.
Yep. Hear you.
Awesome. So I just wanted to jump in here, and there's a question that one of the reasons why I wanted to talk about these topics is because of that massive gap between what's actually done in the field and what, like on the design side, what should be done. And so to be able to get like ASHRAE 221, like, to be honest, I didn't, until I talked to you, Ben, a couple weeks ago, I didn't even know, and you, Jeremy, like, I didn't even know that it existed. 310, I've been hearing that from MACA for a while. And so like what's it gonna take to be able to get these standards to go from kind of being in this kind of nascent form of finishing development and starting to be injected into the ecosystem? How are we going to get the majority of HVAC contractors to start using, or like, I guess, start complying with these types of processes?
Yeah, I think one key is going to be the tools that are out there to be able to do this. I'm showing this Excel spreadsheet calculator here, and not a lot of HVAC technicians are going to want to jump in and pop out their laptop or their tablet or whatever and crank through an Excel calculator. So the more we can automate some of these calculations and the data collection through tools like MeasureQuick, the better, I think. And then from there, I think it's just about steadily trying to get adoption out there from the highest quality contractors. In some markets, there might be benefits to requiring some of this testing. And I know like 310 is required in some areas, or things that are very similar to 310. But, really for the best contractors out there, they should be looking at this stuff and saying, oh yeah, I want to give my customers what they're paying for. I want to set myself apart from the competition and be able to, show that I actually install systems that perform.
I think one thing that goes understated in getting this stuff out into the ethosphere, so to speak, it, like you said, is number one is the tools, that's for sure, and automating it. But second to that is the infusion of youth in our industry. So there's a lot of people that were used to doing things one way, and like we use these different rules of thumbs and metrics, and all that's changing. And as the youth come into the system and they start getting trained up on this stuff, I think if we start implementing it right at the training process and putting it in front of them as something that should be done and can be done, and they're able to see it as they get worked into the HVAC system, it's just going to become something that's natural to them, because we got to get away from the older thinking of, don't look at what I'm doing and let's get in and out as quick as possible and all that. that, and sort of like these guys today, like people want, like in the internet era, people want to be able to see everything. It's a data driven society that we live in. And if we can show the value of the data to the people that are getting trained right off the bat, then I think that goes a long way and just slowly working this stuff into just everyday practices.
See, I'll jump on and do a lot of me too for that. Yes, we need to promote those contractors who are doing it right and make sure that they're highlighted. I think that you're right, Jeremy. I think the youth of today, I haven't used a Bluetooth meter. You mentioned the Bluetooth. I'm thinking, great Scott, what in the world? That's you kids today with your fancy tools. No, I think it's great. The other thing is the value proposition. We were talking about standard 310. And if builders understand that this is stuff they've always expected to be done, right? They chop their price down to next to nothing, but they still want the quality. And so I think if they see that they may be accepting a proposal that's better than everyone else's, but the quality at the other end, the measured, confirmed quality at the other end is not there, they may be willing to increase what they're willing to spend in order to get the product that they want to deliver to their customer. So I think it's an education effort to be sure.
In one of my, just to piggyback that, in one of the sales classes that I've taken over the years, I can't remember which one it is. But a statement that always stuck with me is you have to be able to prove the pain. So if you can prove the pain that you're going to no longer have once
Right.
they start using this, then they're going to be able to see it. And you saying that about the builders made me think about that, because a lot of times the only time we hear from the builder after the stuff is built is when something's going wrong. You don't hear about anything that was done right or correctly.
Nope.
So, you know, that is a big piece of it for sure.
And they know their callback numbers. They know how many times they get called, or the good ones do, both builders and HVAC professionals. So a great way to lower those callbacks is to do the job right the first time. And if you're following ASHRAE 221, or you're using MeasureQuick and the quality installation app, or the quality installation certificate aspect of that, and you're confirming that, yes, this system was installed correctly, that's big.
Fantastic. Well, thank you, all three of you, for sharing your insights on this very special topic and very important one. Wes, Ben, Jeremy, this has been an incredible session. And so with that concludes our Q&A section, but please do send over questions as you have them, those in the audience. So finally, we will hand it over to Brent, who will give us a quick message and share a little bit about the Heat Pump Summit, which is coming up just in these coming weeks.
Awesome. Hey everyone, my name is Brent and I'm here to tell you about the Heat Pump Summit. It's a conference training event for contractors happening in Berkeley, California on November 13th. This event, 3 parts to it. There's a detailed training day, conference content, and trade show tables. It's important to note that this event does cover both HVAC and water heating. Quick run through some of the interesting stuff that'll be happening here. The training is really focused on covering from start to finish, from sales through commissioning. Folks like Larry Waters of Electrify My Home, he's going to be talking about successful business with electrification. He's been doing heat pumps only for many years. Building engineer Ben Knopp, he's going to talk about detailed design. Really interesting live demonstration model, kind of correcting some common myths of basic fluid dynamics that affects HVAC. And MeasureQuick's Joe Medosh is going to be there, rounding that out with commissioning. Also, a REAM manufacturer training will be happening, and for folks out in California, that'll qualify you for the TechClean California's new heat pump water heater rebate. Conference content is all targeted at contractors, very tactical stuff. Bunch of strategies around like fitting new load into the electrical panel, emergency retrofit installs, successful strategies for that, both in air and water. Lots more to cover. Check out the heatpumpsummit.org website for the full lineup. And it's going to be a jam-packed day. Everything's really from that building science-based approach. And the goal of the event is just to make happy heat pump customers, size small for the grid, and meet other experts by attending the summit. We can give a discount for folks on this webinar, MQ100 for Measure Quick. MQ100 gets $100 off. And we've got a great hotel rate, $139, DoubleTree on the San Francisco Bay. And more info, like I said, heatpumpsummit.org. And you can reach me, Brent, at heatpumpsummit.org. That's what I got for you. Thanks.
Thank you so much, Brent. So with that, thank you again to our guests, Wes, Ben, and Jeremy, for sharing so much about commissioning and standards today, and the convergence of design and commissioning. And finally, how these standards will get applied in this heat pump transition. And then thank you everyone who has joined in the audience today as we chart our course to a more efficient and sustainable future in residential HVAC. If you're interested in joining and learning more in these series of webinars, we will be disclosing when those will be coming up in the coming few days. So please stay tuned. I'll hand it over to Ben Reed to close us out right now.
Thank you. Just I wanted to add to that, saying I think the final webinar or the next webinar is going to be Tuesday at 11 a.m. Eastern. That is the tentative plan so far. And it's going to be about the real world application of basically the commissioning process. So we got Chris Hughes from the Energy Conservatory, who's going to be jumping in on that. And also Ben Knopp from, I think, Community Housing Partners, who is also going to be at the Heat Pump Summit in a few weeks. So they'll be talking about, what it takes to do commissioning from the perspective of either an HVAC technician or contractor, and maybe some of the pitfalls, some of the gotchas, and how to be able to do it in the most effective way possible. So yeah, hope to see you next week.